Okay, so today we're going to be going over our first test. There's actually 9 of them for this course. There are many more tests. Maybe we'll have some time to go over a 10th one. But our first test is the convergence test of a geometric series. Now, in order to understand a series, here I listed what an infinite series looks like. Our course depends on you understanding an infinite series. Each term is indicated here of the sequence. So when you have a series, you have the sum of the terms in a sequence. Okay, here's the nth term. So a lot of times your nth term expression helps you have an explicit formula for any term of the sequence. Okay, so we're going to go over that a little bit, just very briefly. So like I said, series is our interest, and to understand a series, you may be looking at partial sums, okay? And your denoted partial sums would be S sub n. Arrow, partial sums. Okay, so hopefully you had enough time to write down what is in here. This was actually the do now. Let me cut to our example problems. Okay, so we're talking about partial sums, and this diagram is going to help us understand a geometric distribution, so to understand our geometric series. So this is supposed to be a square, a 1 by 1 square. And I want to be able to connect the midpoints, okay, but in such a way that I'm connecting them from opposite sides. So I'm going to do one at a time. So I'm taking that one, okay, not the other one. So one or the other. And I want to try to find the area. So the area of this is going to be 1/2 times 1. So if I'm just finding the sum of just this one piece, S sub 1, it's going to be 1/2. Now, if I want to continue to find the sum of the areas that I'm creating by doing half, let me take a different color here, of what is partitioned, okay, and there's other problems too where you're connecting the midpoints in a different way. This is a horrible drawing, but it's essentially the same thing. Then you find the area and the area and the area like this, okay. It's horrible, but you can see how we're just like keep taking more and more. All right, so the second one, okay, that one that I did in red, its area is going to end up being 1/2 times 1/2. Which is 1/4. So the sum together is, this is the previous sum, and you get 1/4. And basically, I'm going to keep doing this kind of diagram. Let's say I want this piece done in, okay? So that seems to be 1/4 times 1/2. Okay, so the sum of my areas now is 1/2 plus 1/4 plus 1/8. And we can keep going. So imagine if we keep going and we keep taking the area of half and half and half and half. Okay, so we could be doing this over and over and over again. So a couple things I want to note to you. This is a geometric sequence. If you just look at the numbers, you're multiplying by 1/2 each time. We call that the common ratio. Okay, and if we keep doing this over and over again, eventually, maybe not even in my lifetime, but we're not going to be able to figure out the sum in a lifetime, but eventually, as like the number of all the areas keep going, we should get the sum to be 1, because that's the area. It's a 1 by 1 square. So that means that for a geometric sequence like this, if you're finding the sum, you should be able to find the area even if it's for an infinite series. Okay, so as you kind of notice here, I was writing down the limit. So the limit of the sum of a sub k as k approaches 1. It doesn't matter if it's k or j or anything. And it goes to the nth term. I have to squeeze an n up there. This is going to equal the limit of the sum of like n terms as n approaches infinity. That's what we're doing. And it turns out to be 1. All right, so now you really got your feet wet into understanding a geometric series and that we can get an answer. So that is called convergence. It would come to this sum. So let's look at our series and figure out the formula. So if we were talking about that a sub k, what that would be, and as well as what that convergence test is. Okay, so while I go over what we're looking at as far as our geometric sequence or series, we need to get the terms of the sequence. I'm going to write that out so you know what that could be, and you guys copy this down, okay? So it's basically 2 parts. Either 1, it converges to the sum, or 2, it diverges, okay? I just kind of grouped it up there so you can see it. All right, let me see if I can make that bigger for you. Sorry, hope you're not being dizzy with the video. Here we go. So if you look at our terms of the sequence we're working with, it is 1 over 2 to some power, to the n. And remember I said that this is geometric. Usually you see their common ratio to some power. And that power has to be n or whatever you're using. You can make that a k, a j, and I. Typically we don't use x. That's for later series that we look at. And yeah, that's how you can identify your common ratio. So let's use this convergence test and look at different examples. Okay, so in our examples, we want to determine if the following is a geometric series. Then we want to tell whether the series converges or diverges. If it does converge, we want to be able to find the sum. Okay, so hopefully you can jot down these sums. If you need to, pause the video and make sure that these are in your notes. Okay, I'm going to read it, so this is going to give you a bit more time. So it's the sum of 5 times 1/2 raised to the quantity of n minus 1 as n equals 1 and we go to infinity. That's how we're going to find our sum. So it is an infinite series, but is it a geometric one? Okay, the answer here is yes. Okay, because r is equal to 1/2. All right, so let's take a look at the next thing we have to do. Determine if our series converges or diverges. So now that you know that r is equal to 1/2, okay, sometimes just call the ratio. If it's between -1 and 1, which it is, that means that this converges. And we usually say to whatever the sum is. Now to find the sum, okay, the formula is to do the first term, and that lower number can be any number, okay? Usually it's 1 or 0, so we're going to plug it into this expression. Divided by 1 minus your common ratio. So if we do that and we simplify this, we're going to get 10. And that is our answer. So let's take a look at number 2. So in number 2, okay, we have the sum of 5/2 to the k power. K equals 0, we go to find the sum to infinity. So this is an infinite series. Now, in this case, it is also a geometric series halves. R is 5 halves. Little note, if, let's say, the 2 and the k are switched, that is a completely different series, okay? So you can't have your exponent be a constant. All right, so now that we know that that is true, let's take a look if it converges or diverges, okay? So if R is greater than or equal to 1, okay, note if it's less than or equal to 1, this means that it diverges, okay, and we do not have a sum. And that's it. This is your convergence test of a geometric series. If you have any questions, let me know. Good luck.